Welcome to the second Hub Framework session. In this episode, we're going to talk about components and how you can create them. Now, in the first episode, we talked about content operations and how you can use them to declare the view models that you want to render in Hub Framework provided view controllers. In this episode, we're going to take a closer look at those view controllers and the components that they are made up of. So all the UI in a Hub Framework view is represented by components, and those components are rendered using component models that are included in the view model. So each of these component models will be mapped to a component implementation by the framework. Components, they come in three different variants: header, body, and overlay. A header component is just a single component that is rendered at the top of the screen, and it doesn't scroll along the rest of the content of the view. Body components are the main components that make up the content that you want to render, and overlays are small components that are rendered at the center of the screen on top of everything else. But what all these different components have in common is that they're all really thin wrappers around a UI view. One way of looking at components really is that there are thin and lightweight view controllers. In fact, if we take the component model, the component, and the UI view and put them side by side, we can see that this fits pretty neatly into the MVC paradigm where the component becomes the controller. So the responsibility of a hub component is really to take a component model and render it using a UI view. And that gives you a lot of flexibility as an API user, because you can use any UI view that you want to render your components. The framework doesn't really impose any restrictions on it. So let's take a look at an example and how we can use a hub component to create a row using a table view cell. So what we're going to do here is create a component that looks like this, just a standard normal table view cell. And we're going to do that by conforming to the hub component protocol in a custom object. And then we're going to use the system provided UI table view cell to actually render this component. So what steps are involved in actually making this happen? Well, there are 5 tasks that we're going to have to go through in order to build this component, starting with defining layout traits. Now, in the Hub framework, the views are very dynamic. They can basically consist of any UI in any different combination. And that poses some challenges when it comes to layouts. How does each of these components behave, and what margin do they want to other components? And this is where layout traits come in. For example, our row component here wants to stretch the entire width of the view, so it uses the full width layout trait to declare to the framework that that's how it wants to be laid out. At the same time, it wants to be stacked on top of other components which are similar. So we don't want to have a lot of spacing in between all of these rows. We want them to behave just like they do in a normal table view. So that's when we use the stackable layout traits. Now, just to give you an example, what would happen if we remove the stackable layout trait from this component? Well, then what would happen is that the layout manager would actually add margin in between all of these components, which would make it look like this. At the same time, if we replace the full width layout trait with a compact width layout trait, then the layout would look like this. So we would have additional margin in between each component on the horizontal axis. Now, this gives you a lot of power because you can very easily define how you want your component to behave in terms of layout with just assigning traits. You don't have to do any manual frame calculations or any manual margin calculations. And this also enables components to be fully decoupled from each other. They don't need to be aware of how they are rendered next to another one of them. They can all just define layout traits, and then we can have a central layout system that computes the absolute margins between each one. So that's the first part with layouts. The second is that we want to make sure that we load the view of our components. Now, just like a UI view controller, we lazily load the views of components whenever they're needed, so that we don't use a lot of extra memory and we don't have a huge performance spike up front when we have to load all the views of all the components. So just like a view controller, a component will get sent the load view message whenever it's time to load its view. and then it's responsible for assigning a view property on itself. And again, this can be any UI view that you want, so you can use all of UIKit and what it has to offer to create your components. And it's very easy to reuse existing custom views that you might have because you can just assign them back to the view property. In this case, we're going to use UI table view cell, so we're just going to instantiate a new instance of it and assign it back to our view property. Next up is calculating our preferred view size. Now, before we talked about layout traits and how that's used to compute margin between different components. But there's another piece to the layout puzzle, and that is what size do you want your component to be? So each component is actually responsible for calculating their preferred view size. How does a component do that? Well, it gets access to two pieces of information. The first is the model that it's about to render, so it can use that to make decisions on how big it wants to be. The second parameter that it gets is the container size that it's about to be rendered in. And that can either be the root view, or it can be a parent if the component is going to be used as a child component. And then what it does, is that it returns the view size that it would prefer to be. In this case, what we're going to do is we're going to take the entire width of the container and a value for our height. Now, important to note here is that we explicitly named it preferred view size, since we want to have the ability to override that in case it's invalid or impossible to achieve. For example, if the width is larger than the container width. Alright, so now we've done that. The next part is preparing our view for reuse. Now, just like in a normal collection view or table view, we are utilizing cell reuse to make sure that we don't consume a lot of memory and run into performance issues when we have large data sets. So as the user scrolls the view, we're going to reuse components that are of the same type. So in this case, you can see that I have two types of components, A and B, and they each have a couple of instances. 3 instances of A and 4 instances of B in this case. Now, when I'm scrolling the view down, you can see that A1 is actually going to be reused when a new A component is about to be rendered at the bottom. This works exactly the same way you expect it to work if you've been using UI table view or UI collection view. There is a prepare view for reuse message that gets sent to each component. And in this case, since we're using an already reusable view, what we can do is we can just forward that call to our table view cell. So we can just tell the cell to prepare itself for reuse. Common tasks in this method would be to clear out any images or other state that you might have in your UI so that you're ready to render a new model. And that is actually the final piece of the puzzle. So the final task that we have to do is rendering a model. So before we had a look at the kind of MVC overview of how a component relates to its view and its model. Now, we've already implemented our view as a UI table view cell, so that's done. And our table view cell has two properties that we're interested in, its text label and its detail text label. Now, conveniently enough, the model has matching properties for those outlets. So we have a title on our component model and a subtitle. So what the component is really responsible of doing here is to really hook these things up. It's going to be sent a configure view with model message, which contains the model that it's about to render. And what the component is then going to do is simply assign the text of the text label to the title value of the model, and the same thing for the subtitle. And that way, we have now successfully rendered our components. So that's how we implement a component, but how does the framework get aware of it? How does it know that we can now use this component, and how is it resolved? So we have now created our row component, so that's ready and done. Next, what we need to do is we need to create a component factory. We use the factory pattern all across the Hub framework because it enables us to create new instances of a certain class very easily without having to enforce a certain initializer. So you're able to do dependency injection into your own classes instead of having to conform to one specific initializer. Now, as you can see here in this diagram, the component factory gets a name that it resolves a component implementation for. In our case, it might be the row name that it resolves to your row components. And then the component factory is registered into the framework in the component registry for a certain namespace. And then when a model shows up that has a component identifier that matches this namespace, the components registry is going to call this component factory with the name part of the identifier and ask it to resolve this component. So in our case, we would be invoked using the row name, and we would resolve the row component ourselves. Now this is also pretty nice because it enables you to do things like fallbacks and delegate between different factories. Since you are in control of creating your own components, the framework doesn't do it magically. Alright, so that's a quick introduction to Hub Framework components and how you can build them and register them with the framework. There's a lot more information available in our component programming guide, which you can reach from our documentation portal in the Hub Framework repo. There you can learn about how you can also extend components to support things like children, actions, and various selection states. So make sure you check that out if you want to learn more, and thank you for watching.